So what is HTML? What does the term HTML even mean, and how does it relate to the web? In a minute, we'll talk about the big picture of three technologies that drive the web: HTML, CSS, and JavaScript. But where does HTML fit? In other words, precisely what role does HTML play in web development? As we go along, you will see that understanding the answers to these pretty simple questions will actually help you make correct coding decisions down the line. Well, first of all, so what does HTML stand for? Well, it stands for Hypertext Markup Language. So let's go over each one of these words and find out what exactly they mean. So first of all, hypertext. Well, hypertext is text which contains links to other texts. And that's basically the entire web, right? One document points to another document or points to a bunch of other documents, and it grows on and on. Sometimes they link back to the original document, and it becomes one gigantic web. And obviously, it's not just about text nowadays. Hypermedia plays a huge role in the web today. You can watch videos, listen to music, and really hypermedia is just an extension of hypertext. The next term is markup. So markup means to mark something up, to annotate. So for example, it's really all about content. On the web, it's all about content. So if you have some content, for example, if you have a document you're writing called Why I Love This Course, which is, I'm sure, going to be the title of your next blog post, that's the content. And you want to annotate the content to tell the browser or to tell some other machine out there, some other program out there, what this content is. And that's what HTML does. So HTML goes and surrounds and wraps that content in some markup language like tags. So you could see here, Why I Love This Course is wrapped around with a title tag, which kind of tells us and some other software out there that this is the title of this document. Which brings me to the first big point. HTML is human readable. So these tags look like instructions for a document structure. You don't need to run it through some interpreter in order to understand the output structure of the document. It's very clear what it is. The last word in hypertext markup language is language. And language basically implies that it has its own syntax, meaning there's a right and a wrong way to code it. So for instance, in the example on the left, the closing div tag appears after the closing h1 tag. So its closing order is switched, which causes parsing and potentially rendering errors. So HTML is language. You could actually code it up in a way such that it's wrong and something will break. HTML also has its own semantics, which means tag names can mean something either to machines or to humans. Okay, so let's talk about the three technologies that drive the web. Each one has its own distinctive purpose, and all three of them fit very nicely together. Let's start with HTML. HTML provides the structure, which means what components does the HTML document have. For example, it can have one heading, 2 paragraphs, and a footer. Note that that does not tell you anything about how these components are visually laid out or what they look like, what color they are, what font size they are. It only tells you what are the components. Like in a house, if you have 3 rooms and a kitchen, you don't really know what color the kitchen is, what color the walls of the kitchen are, and the only thing you know is what components make up the house. The color and style is the role of CSS. So colors, layouts, font sizes, in other words, any stylistic types of things. So for example, if we have a heading in our HTML document, it will tell us what color and what font size it is. So that's the job of CSS. And the third, JavaScript, its job is to provide behavior, provide functionality. It adds functionality to the page. So for example, what happens when an HTML document finishes loading into the browser? Or what happens if I click on one of the headings? That's the job of JavaScript, to provide that behavior. Let's take a look at a quick example of these concepts in action. Okay, so the example that we're going to take a look at is located in the examples lecture 01 folder. And the file we're going to look at is called structure-only-before.html. And it's a simple HTML file. There's nothing but some HTML and the dummy text data here, dummy text. And it's got a title, it's got the heading here, a couple of paragraphs, and this has a footer where in the footer we have the tech support email address for the poor soul who is going to try to contact this technical support. Joking, obviously. Okay, so basically nothing more than this, just HTML and some dummy text. And we're also going to take a look at structure-only-after.html, where it's the exact same HTML document, but we inserted some styles into it and some behavior as well. So we made for example, the heading, we made it green, and we center aligned it. The second paragraph has some margin applied to it. The footer here has a paragraph with our tech support email, and if we click on the tech support email, it's going to pop up an alert for us. Okay, so let's take a look at both of these documents in the browser. Okay, so here's the first document. There's nothing special about it. It's got that title that we talked about, a couple of paragraphs, and the tech support email at the bottom in the footer. And if I click on it, nothing actually happens. But if we look at document number 2, we see that HTML is structure only heading is now green, and it's much bigger title. And we see that the position of it is moved to the center. And we also see that the second paragraph is in the center, and it's much bigger font compared to before. And if we click on the email address that we talked about, we see an alert gets popped up with the message emailing us is useless, which sounds just about right for most people's experiences with tech support. So the thing to notice here is that the difference between the two HTML documents are the styles and the behavior were applied, but the structure of both HTML documents is exactly the same. So in summary, we spoke about HTML and the fact that its job is to annotate content and define document structure. And obviously, as any language, it has a right and wrong syntax, which you'll have to learn in order to code it. And the 3 core web technologies, HTML, CSS, and JavaScript, work very well together because each one of them has its own distinct and precise role, and they kind of don't really step on each other. They work very nicely together. Next, we'll talk about a bit of a relevant history of the HTML standard. And I do mean relevant. Let's briefly talk about the history of HTML. It's usually the case that the history of any technology is not particularly interesting or exciting, and I can't claim that the history of HTML is that interesting either, but there are certain parts of this history that not only give you an understanding of how this technology was developed, but also gives you an appreciation of certain aspects of HTML that are still relevant and applicable today. So before 1997, there were no community standards. So browsers basically did whatever they wanted. They invented new tags. They implemented the same tags differently. It was kind of the wild west of the web. And you could go to a website and end up being told that your browser is not compatible with this website, so you have to go get a different browser in order to even view the website to begin with. Now, around 1997, the World Wide Web Consortium, the W3C, came up with the first standard browsers actually started to pay somewhat attention to, which is HTML4, and they very quickly updated it to HTML 4.01. That standard was pretty loose, and the browsers still had way too much leeway inside that standard as to how they implemented it and how pages were being rendered. So around 2000, the W3C came up with another specification called XHTML 1.0, and that specification was based on XML. And XML is a very rigid but very clear markup language. And W3C wanted to kind of pick that up and keep going with it and produce XHTML 2.0. The problem is that the browser vendors, which at this point already had a history of not really listening 100% to any standard, they decided that this whole W3C thing is moving way too slowly, and on top of that, they felt that the specifications are really moving in the wrong direction. So the browser vendors banded together, and they created yet another group that produced specifications that was called WHATWG. And WHATWG, that's yet another abbreviation because we don't have enough of them. So that group is called WHATWG, and it stands for Web Hypertext Application Technology Group. So it's a bunch of browser vendors that got together, and this group is much less democratic than the W3C. In other words, they have one editor that makes the final decision. So all the browser vendor representatives can argue argue all they want, but at the end they appointed one editor that kind of makes the final decisions. And they're the ones that are driving the entire HTML5, what we have now. They're the drivers behind it. So for a long time, the two organizations didn't really see eye to eye much at all, and they didn't work together. So they were really going to two different directions. But I think W3C eventually realized that, hey, that organization is actually being driven by the people and by the companies that actually matter, because they're the guys who are developing the browsers themselves. So maybe it's a good idea to kind of make peace and try to see if we can work together somehow. And this is what happened around 2007, 2009 timeframe. So Whatwig and W3C started sort of kind of working together. And what they produced in the end is what we have now, HTML5. So what does any of that matter to you? Well, what matters now is that there are two organizations out there. One is W3C and the other one is Whatwig, and they're both in charge of HTML somewhat. So it could be that you can get into a situation, it's certainly possible, that a browser potentially can be compliant with a specification which isn't yet even formalized by the official W3C. So, it makes your head spin a little bit, doesn't it? So the way they divided it up is that W3C is going to be in charge of the standards, since this is what their bread and butter is, it's standards, and they're going to be in charge of the HTML5 standard. And Whatwig is not even going to give a version to their HTML standard. They're just going to say it's HTML and it's constantly evolving. There is no version. We never stop. We keep evolving it. And Whatwig, since they're the ones that really implement the browsers. So what W3C does is it kind of cherry picks some of the more successful things that are actually kind of start to be implemented by the browsers, and they slowly bring it into the official standard. So the point of this quick history lesson is that this whole thing is a bit of a muddy waters, and it's kind of hard to keep track of, well, what is the browser supposed to be compliant with? But unfortunately, it is our job as developers to keep track of these capabilities. And it is particularly important nowadays because all the major modern browsers are all evergreen browsers. And what that means is that they silently update themselves on users' computers. So you no longer even need to have the user acknowledge the fact that they want to update. That means that, which is a good thing actually, right? Because now every browser is kind of patched as much as they can be patched for security reasons. And also it kind of automatically, without the user intervention, gets the latest, greatest features of HTML5 and all of the browser software itself. But every major browser, Chrome, Firefox, Safari, Internet Explorer, they all are evergreen browsers, so they update themselves automatically. So what I would like to do now is give you a few resources on the web that will make this job of keeping track of these changes a little bit easier. The first resource that I really should share is the W3C HTML5 standard. And this is a very academic type of a reading, but you can still look stuff up in it that, that is somewhat useful. And certainly if you want to kind of know what the actual standard is that everybody agreed to, this is a great document to start with. Another excellent site that you should definitely check out and kind of keep in your arsenal is caniuse.com. And this is a site that basically itself keeps track of HTML5 standard, SVG standard, CSS standard, JavaScript APIs, and on and on and on in the web space to be able to tell you which browser supports what. So for example, if I search for source set, which is a pretty new attribute that is going to hopefully come soon to the image tags, which we'll talk about it later. But you could take a look, see if when I type source set, it'll tell you, well, this is an attribute, and will also tell you which browsers at this point support it and which ones, like IE, do not. And you could yourself take a look at and see whether or not, something that, a browser, let's say you're not really targeting, don't care so much about, if it doesn't support it fully, you could make the decision whether or not you want to use that particular feature. Another great resource to find out whether or not your HTML actually is going to work in browsers is to use a validator. And there's a great validator provided by the w3.org website. And you could basically cut and paste the URL of your website straight here, or you could upload a particular HTML file, or at this point you could even copy and paste your HTML straight in here and check whether or not it's valid. And if it is valid, chances are, very high chances are, that it will work very well in the browser. So let's take a look and see, let's test it out and see if we could validate the W3C's own page. And if we click check, and sure enough, it tells us that it is valid or everything is green. Now, when you write web pages in the real world, you can't always say that I'm just going to go ahead and try to support every browser that exists in the entire webosphere. And that's not going to work because there are just so many of them and some of them are so outdated. So it's always a good idea to check the browser statistics and to see, certainly if you're in an organization that you know all the browsers that are in that organization that are being used, all the browsers and browser versions, that helps. But if you're writing the web, writing an application for the entire web, it's good to know, well, which browsers are actually popular and which browsers are basically falling off the edge. And if you take a look here, this is a website, w3schools.com, gives you the browser statistics. And if you take a look here, in September of 2015, Chrome was basically crushing its competition. And you can see the next one is almost 3 times less market share than Chrome. And you could tell that 65, 66 almost % of users on the web are using Chrome, so that seems like a pretty important browser to make sure that your web page works in. And if you're all the way at 1.4% of market share, if there's some feature that you really, really want to implement, and all the other browsers implement it, but one of them that has such little market share doesn't implement, well, you might want to decide to go with it anyway. This is something that you can make a decision about. And last but not least is Google.com or any other really search engine that you would like to use. I don't think there's a day that goes by that in web development that you don't have to look something up on the web. And this is just part of the day-to-day business. And if you're going to be in web development, you kind of have to get used to the fact that you have to constantly look things up. Things are constantly changing, and obviously no human being can know it all by themselves. So to summarize, we went over somewhat relevant, hopefully, history of HTML and kind of saw how it affects us as developers even today. So I gave you some resources for validation of HTML, which kind of gives you a little bit more of a comfort factor that your HTML will work in browsers properly. And I gave you some resources for feature investigation, like the website of caniuse.com, which lets you know whether or not a particular feature is implemented in a particular version of a browser. And we also went over where you could look up browser statistics so you could make an informed decision of what browsers you should even target for your web application to begin with. Next, we're going to talk about the anatomy of an HTML tag. We'll take it apart and see what an HTML tag is and how to properly code it. At the core of HTML is the HTML tag. So it's pretty important to understand what HTML tag consists of and how to syntactically properly code up an HTML tag. Usually, HTML tags have an opening and a closing tag, and they surround some content. In this case, the tag P, which stands for paragraph, is communicating to us that the content in the gray area should be treated as a paragraph. Now, technically speaking, P by itself is called an element, and together with the angle brackets, it's called a tag. But the truth is, the term is used so interchangeably that whenever somebody refers to an element P or a tag P, they really could mean one and the same thing. Now, most of HTML tags have a closing tag that matches its opening tag, but not all. For example, the BR and HR tag, BR stands for line break and HR stands for horizontal rule, only have an opening tag. They don't have a closing tag at all. Now, every HTML element can have predefined attributes. So we will learn some of the most common ones as we progress in the course, but here's what you need to know about tag attributes in general. Attribute is a name-value pair that is kind of a metadata about the element itself that it's being applied to. So in this example, we're assigning my ID as the value of the ID attribute. Each attribute has its own rules for the meaning of its value. So for example, ID attribute being assigned in as example has to be unique within the scope of the entire HTML document. In other words, no other element of any kind in the web page is allowed to have its ID attribute equal to the string myID. If there's another element with the same value for ID, that would mean that the web page contains invalid HTML, which can potentially break some styling or even functionality of the page. Now let me go over some of the basic spacing rules. No space is allowed to exist between the opening bracket and the tag name. And likewise, space is not allowed between the opening bracket and the / of the closing tag. However, you must have at least one space between the tag itself and any of its attributes. And space is allowed everywhere else and is simply ignored. So if you have extra space after the P element in the opening tag, or if you have extra space between the equal sign of the attribute name and attribute value, or you have other spaces, even return characters, all that is completely ignored by the browser. One more rule. Attributes can only be specified on the opening tag, so you can't specify an attribute on the closing tag. Now let's talk about the value of attributes for a minute. In HTML5, enclosing the value of the attribute in quotes is technically actually not required in all circumstances, but nevertheless, it's best practice to always surround the value of the attribute in either single or double quotes. It doesn't matter whether you use single or double quotes, they really are equivalent in HTML. A more interesting case arises when the value of the attribute itself contains quotes, so the actual value has quotes as part of its value. In this type of situation, the only thing you have to watch out for is making sure you close the quote in the opposite order of opening them. So if the last quote was a single quote, it must be closed first. Which quotes you start with doesn't make any difference. You could start with double quotes, as we have in the example here, or you could start with single quotes. You can also nest these as many times as you want, as long as you close them, obviously, in the proper order. But in practice, it's kind of very rare that you have to have more than 2 levels of quotes. Any more than that, and your code just becomes messy and hard to read. Now, if you've dealt with previous versions of HTML, especially XHTML, you might be familiar with the idea of a self-closing tag. A self-closing tag is basically an XML type of shorthand notation for a tag that happens to not to contain any content. For example, if we wanted to have a placeholder in our HTML document for some other content that we'll dynamically perhaps insert at some later point, that would be one example when we would need to have an HTML tag that has no content to begin with. However, in HTML5, the tags are a little bit more semantic. So if an HTML5 tag is capable, meaning it can possibly ever have some content, it is illegal for that tag to be self-closing, even if there's no content at the moment. So instead, you have to provide an opening and the closing tags without any space in between them to signify and to communicate the lack of content as surrounded by this tag. So in summary, we went over the anatomy of an HTML tag, the opening, the closing tags, the fact that it can have attributes describing what the tag itself is. Remember, they could use double and single quotes interchangeably. Just make sure that if there's actual quotes in the value of an attribute, you have to interchange them in the same order that you open them. You have to close them in the opposite order. And we also went over how to specify a tag without any content inside HTML5, for which the rules are a little bit different than for the previous versions of HTML. Next, we're going to talk about how to create the basic HTML document structure. In this lecture, we're going to create a basic HTML document structure by going straight to the editor and coding one up ourselves, and then we'll validate it on the W3C web validator site. Okay, so I'm in Sublime Text, and I have a document open, a file open called doc-structure-before.html. And it's located in the examples lecture 04 folder. So we have a blank slate in front of us, and we're going to create our very first HTML page. So every HTML page should start with the doc type or document type declaration. The words doc type or HTML could be in lower or uppercase. The only thing you have to watch out for is that there shouldn't be any space between less than, exclamation point, and the word doc type. You can have as much space as you want everywhere else, but it just doesn't look that great, so we'll just keep it to one space. In the past, these declarations were pretty complicated looking. Certainly not too many people would be able to type them up without copy and paste. HTML5, however, changed all that. Now the declaration is as simple as it can be. All it does is tell the browser that it should get ready to render HTML. Now I know what some of you might be thinking. What else would there be if not HTML? There doesn't seem to be any practical purpose for this declaration. If you're thinking that, you're absolutely right. This declaration is really largely historical. When HTML standards were first becoming popular, the web was full of pages that were not compliant to the standards. To help browsers render those older pages correctly, browsers used the duck type declaration to distinguish between non-compliant and compliant pages. Non-compliant pages were rendered in what's called the quirks mode, and the compliant pages were rendered in what's called the standards mode. Now that's all historical, but what you need to know today is that if you leave off the HTML page declaration, that will signal to the browser that it should treat your pages as one not following HTML standard. I'm not going to go into what that actually would mean in practice, but needless to say, things will be a bit messed up. Your layout wouldn't work quite right, the styles you apply would work a bit, well, quirky. So to make a long story short, always use the simple HTML5 duck type declaration. Next goes the HTML tag, and that's basically the tag that contains the entire HTML document. After the HTML tag goes the head tag. The head tag contains items that describe the main content of the page. Things like what character encoding should the browser use for the main content. It can contain author's description of the page title, and whatever other external resources are needed to render the page properly, among other things. The point is, it contains some metadata about the main content. Let's write our first meta tag to specify the character set encoding of our web page. While not absolutely required, it's always a good idea to specify the character set that the browser should know how to interpret the content of the web page. The most commonly used character set is UTF-8. Also note that the meta tag is a standalone tag. There is no closing meta tag. Next, we'll specify the title of the page. The title is one of the tags that is actually required to be here. Without it, the HTML will be invalid. After the head tag goes the body tag. The body tag is the root of all content that is visible to the user. It is often referred to as a viewport. We can now write our content. Okay, so let's take a look at how this looks in the browser. Okay, and here's our page. You can see the content, Coursera is so cool, I'm learning so much, and you can see that the title, Coursera is cool, is also there. Next, let's try to take the code from our page and copy and paste it to validate it inside the W3C validator. And it says we're valid. I'm sure you've noticed by now that what we're doing is nesting one HTML tag into another. So for example, we could say that the head tag contains the title tag. One important rule when nesting HTML tags is that you have to close the last opened tag before you close its parent tag. If you don't, the HTML you wrote is invalid. So for example, here I have a paragraph, and don't worry about what these tags mean at the moment, but the paragraph tag, P, is closed before the last open tag, span. Span is closed after. So if we copy and paste this code and place it inside our validator and check it, you'll see that it's complaining and saying that the end tag P seen, but there were open elements. In other words, it wants us to close the span tag, which was opened last, before we close the outer P paragraph tag. One more note before we move on. When the browser opens an HTML page, it always renders or interprets the HTML code sequentially from top to bottom. So the doc type declaration gets interpreted first, then the HTML tag, then the head tag, and on until it hits the last closing HTML tag. This will be important to remember as we progress further into the course. In summary, we went over the bare minimum HTML document, plus we added some. We went over the HTML version declaration, and remember, we always have to use it, otherwise the browser will be put into quarks mode and some things will break. Our first HTML tags, we used HTML, meta, head, title, body, and actually throw in some paragraph tag as well. We went over the fact that HTML is rendered by the browser sequentially, meaning top to bottom, and it renders it top to bottom as well. Next, we're going to talk about HTML content models. The term content model refers to the default behavior the browser applies to the elements belonging to that content model and to the nesting rules of those elements. In other words, which elements are allowed to be nested inside which other elements. Prior to HTML5 specification, HTML elements were either block level or inline elements. HTML5 split these two content models into 7 models, so things got a bit more complicated. Let me go over the 2 traditional models anyway, and I'll explain in a moment why I'm doing that. So all elements fall into basically 2 categories under the traditional content model structure, either block level elements or inline elements. Block level elements render to begin on a new line by default. You could change that with CSS, but we're not talking about CSS at this point yet. So what that means is every time you specify a block level element in HTML, the browser will automatically place that element on a new line in the flow of the document. Block level elements are allowed to contain inline or other block level elements within them. This is in contrast to inline elements, which render on the same line by default. Again, you could change that, but by default, it renders on the same line, which means if you put a whole bunch of inline elements next to each other, they will all be going on the same line, as if there's no new line character present. Inline elements also have a restriction that they can only contain other inline elements. In other words, an inline element cannot have as part of its content a block level element. Now, I told you that HTML5 really replaces these definitions with more complex set of content categories. So why are we going over them now? Well, the reason we go over them now is because this distinction between block level elements and inline elements remains pretty practical because it aligns very well with still existing CSS rules. So even though HTML5 came up with new content model names and new subcategories, and just new way to break them down, at the end of the day, you could still look at all of these as far as your coding is concerned as block level elements and inline elements. And obviously it's a little bit of an oversimplification, but it works. And just to be kind of complete, block level elements roughly translate into the new HTML5 category of flow content, and inline elements roughly translate into the HTML5 category of phrasing content. So let's go look at some code that will demonstrate these concepts. To demonstrate the difference between block level elements and inline elements, we're going to take a look at an HTML document called div and span.html. It's located in the examples lecture 05 folder. Perhaps the most generic elements in each category are the div and the span elements, and these are the elements we're going to introduce in this document. The div element stands for division, and the span element stands for span. The div element is your most generic block level element, and the span element is your super generic inline element. So let's go over this document real quick. We have a couple of divs following one after the other, div 1 and div 2. Then there's a span element that follows div 2, and the number 3 div is a little bit more complex in that it includes a span element inside of it. So let's take a look at what this looks like in the browser. So you could see that div 1 element is all by itself on its own line, and so is div 2 element all by itself in its own line. Now the span 1 was a tag, an element that followed directly after div 2. And even though span is an inline element, since div 2 requires that it be on its own line, it pushes the next inline element to its own line as well. And this is exactly what happens with D3. Even though span is an inline element, technically speaking, the next tag shouldn't really go anywhere but right behind span 1. But since D3 is a block level element, it requires its own line, so it gets pushed to the next line to be by itself. Now the span2 tag is sitting inside the D3, and since it's an inline element, it doesn't cause any more formatting, and it just sits right here inside the D3 without requiring a new line. So just so there's no confusion, the new line characters that follow the div tags make absolutely no difference to the HTML page and how it renders. I could remove all the new line characters, save the document, and preview it in the browser again, and as you could see, in terms of formatting and in terms of requiring new lines, nothing has changed. As the last step, let's try to take the code from our page, copy it, and validate it in the W3C validator. As you can see, the page is valid. But what happens if I go ahead and right inside our validator, add another div tag right inside the span tag with some content? And I'll close the div tag, and let's check the page. And now you could see it's complaining that element div not allowed as a child of span element in this context. And it's telling you the context in which div element may be used is flow content. And content model of span element is phrasing content. And again, phrasing content roughly translates into inline content, and flow content roughly translates into block level content. I'll provide a couple of URLs for you to explore a little bit further into the different categories of the HTML5 content models. But I'd like to demo one real quick, and that is the W3C kinds of content section, where it basically lists the 7 types of content that the HTML5 defines. What's cool about this page is that you could roll over different parts of this graphic, and you could see all the different elements that belong to this particular HTML5 content model category. So to summarize, we compared block level and inline content types, and which we know are not part of the official HTML5 specification, but they're still used quite often in literature and just in regular coding. And they're roughly equivalent to flow content and phrasing content, respectively. Next, we're going to talk about headings, and we're going to explore some new HTML5 semantic elements. Okay, so in this lecture, we're going to talk about heading elements and some new HTML5 semantic elements. First of all, what does the word semantic mean? Well, definition of semantic is relating to meaning in language or logic. In other words, it has some inherent meaning. The names have some inherent meaning. Now, when it applies to HTML, what does semantic HTML element mean? Well, a semantic HTML element is an element that implies some meaning to the content. In other words, it's an element that tells you something about the content, whether its importance, whether it's a little bit of its description. It basically hints to you to that meaning. Now, the reason that's important is because us humans and machines can understand the meaning of that content surrounded by a semantic tag much better than if we just surround it with some tag that doesn't really tell us anything other than this is some sort of a division within the document. And also, it may help search engine rankings. In other words, SEO. And SEO stands for search engine optimization. Now, I stress may here because there is some controversy and disagreement among experts if this is really true. Now, experts who disagree with this say that modern search engines are so sophisticated nowadays that just about nothing other than the content itself affects the ranking of the page. So you're welcome to go and Google for the words "do semantic HTML5 tags help SEO?" and you could see a lot of discussion on this topic. Now, let's take a look at an example of the first type of semantic tags that we're going to look at, the headings. Okay, so here I am in Sublime Text, and I am in the Examples Lecture 06 folder looking at the file called headings.html. And this is a very simple HTML document. It has all the H1 elements, H1, H2, H3, and all the way to the H6 element, or basically all the available heading elements. And what these headings are trying to convey is that the heading content between H1, opening H1, and the closing H1 element is the most important heading in the document, and on and on and on. So H6 would be also a heading of the document, but it's the least important one of them all. So let's take a look at what this document looks like in the browser. And here it is. So we could see the browser defaulted to styling that basically visually tells us that this is the main heading. Heading number 2 is a little less important, and on, all the way to heading, subheading 6, which is the least important of the headings. Couple of important points to understand about these elements. First, even though their default rendering in the browser appears to give them visual distinction, these should not be used for styling. These elements are only meant to convey structure of your HTML page, nothing more. With CSS, any regular div element can be styled to look like any one of these heading tags. So why not just use a div? Because if we did, we would lose the meaning of what a heading is. Second, something that's marked H1 is obviously the most important and generalized description of the content of this page. And while there are disagreements among the SEO experts about how effective these semantic tags are for helping your search engine rank in general, everyone agrees that when it comes to the heading tags, and specifically the H1 tag, that it is of utmost importance to use it, and that it should contain the wording which truly conveys the central topic of the rest of the content. Okay, so let's take a look at another HTML document called semanticelements.html. And that file is located in the examples lecture 06 folder right next to the headings.html file that we just looked at. And in this document, I introduce a whole bunch of new HTML5 semantic tags. And so let's go over them right now. So the first thing you see here is the new header tag. And the header tag basically it contains some header information about the page. So usually it consists of company logo, some tagline, sometimes navigation, actually often navigation is contained within the header as well. As you could see, this is exactly what we have right here. The nav tag signifies some content that is used for navigation within our website. Afterwards, we have our familiar H1 tag, and you should absolutely always have that. And then we have a couple of set of section tags here, and within each section tag, we have a bunch of article elements. If you look at the HTML5 specification, you'll see that the way the section element is defined and the way the article element is defined is that it's usual, or it makes sense, that the article should go inside the section element. However, that is not always the case, and there's certainly no hard rule about it. It's very possible that the article can also have sections within that. So you're certainly not constrained to have this structure. We scroll down, we see we have an aside tag. An aside tag is basically an element that communicates that there's something that is inside of this element that is related to the main content of the page, but not as direct a relationship as the main content. And finally, we have the footer tag, which, just like it sounds, has the footer information in it. Now, the thing to note about all of these tags is they're all block level elements. So as far as we're concerned, visually we might as well have just used the div tags everywhere. However, if you look at the code, it is obvious how much easier it is to read and understand what's going on structurally in this HTML page. For example, you can easily see that article 1, 2, and 3 are somehow related and are somehow different from articles 4, 5, and 6 since they live in two different sections. That's the power of the semantic elements. They inherently convey some meaning. Let's take a look at this page in the browser. As you can see, here's our header element, and the nav element is sitting right inside of it. And as you could see, the section, article, the footer, they're all block level elements, since every single one of them is actually on their own new line. So in summary, well-chosen content for H1 element is crucial to search engine optimization, and you should definitely take advantage of that. And remember, semantic elements do allow you for more meaningful expression of the structure of your HTML code, HTML page, but they don't really give you any more functionality than a regular div or regular span would without it. Next, we're going to talk about structuring content with lists. In this lecture, we're going to talk about HTML lists. Now, lists are an incredibly useful HTML structure that allows you to group related content. If you think about it, we as regular people, we think of things in terms of lists, to-do lists, shopping lists, so on. And so therefore, it's only natural that lists appeal to us as an organization tool. Let's go ahead and jump straight into the code and take a look as to how to implement these lists in HTML. Okay, so I'm in Sublime Text and I'm looking at the document called unordered lists before.html. And the document is located, the file is located in the examples lecture 07 folder. And as you can see here, we have a list here in front of us, my typical dinner shopping list. Milk, donuts, cookies, some different types of cookies, and then obviously at the end, Pepto-Bismol. So what we would like to do is produce a bulleted list in our HTML document. So if you look at the page right now, the way it looks in the browser, as you can see, there is no list. It's just a bunch of spaces in between them. And the reason that is, as I told you before, all the different new line characters or any other separated type of characters like tabs, extra spaces, they're really all ignored by the browser and only one space is honored. And since typically a shopping list is not something you need to buy in order, we can use an unordered list for this example. So the way you create an unordered list is you specify a UL, unordered list, UL tag around your entire content. And every item within the list is an LI tag, otherwise known as list item. So let's go ahead and indent this and surround every one of these items with an LI tag. When we get to the cookies item, we could see that the cookies item contains more than just the word cookies. It actually contains its own list inside of it, which means the content of our LI should really expand not just to cookies, but expand all the way to chocolate, sugar, and peanut butter. And it also means that we need to create another unordered list inside our cookies item. Let's go ahead and indent this, and we'll surround each one of these items in an LI as well. Last but not least, Pepto-Bismol is supposed to be surrounded with an LI tag as well, and that list item really belongs to our original unordered list. So let's save the document, and let's refresh and view it in the browser. And here we go, we have our unordered list. As a last step, let's make sure that we actually wrote HTML that is valid, and we'll cut and paste the HTML into the W3C validator. As you could see, our HTML page is valid. But let's see what happens if I take one of the items in my unordered list and simply remove the LI tags around it. In this case, I removed the LI tag around the Pepto-Bismol list item. If we check it again, we see that the HTML that was written is now invalid, and the reason is it says text not allowed inside UL in this context. And what it's telling you is that the only thing is allowed inside a UL element is an LI element. Anything else is not allowed. There are lists out there that absolutely require some ordering to it. For example, I'm looking at ordered lists before.html in the same folder, examples lecture 07. And here there's a very important procedure called Oreo cookie eating procedure. And it's important that this procedure is followed step by step without mixing up step 1 and step 2. So as you can see, in terms of our HTML, the only difference is that our UL tag got replaced with an OL tag, which stands for ordered list. But the LI items are exactly the same. And the way we treat a sublist within an ordered list is also exactly the same as we treated it within the unordered list. So for example, here we have make a double Oreo, which is a list item that has its own step-by-step instructions, and it does appear inside an OL, which is ordered list, inside the li item. So this item right here contains an ordered list inside of it. Let's take a look what this page looks like in the browser. And here's our ordered list. Oreo cookie eating procedure. Open box, take out cookie, make a double Oreo, has its own list, which is peel off the top part, place another cookie in the middle, and put back the top part. And the fourth one is enjoy. Wow, there's so many things you're learning in this course. In summary, lists provide a natural and commonly used grouping for content. Very often, lists are used for structuring navigation portions of the web page. Next, we're going to talk about HTML character entity references. There are many applications for HTML character entity references. However, in this lecture, I will concentrate only on a particular problem that the entity references can solve for us. Since HTML uses certain characters for its syntax, we need a way to differentiate between those characters as HTML and those same characters as content. If we want the browser to interpret special HTML characters as regular content, we need a way to escape them. In other words, we need a way to tell the browser not to interpret them as HTML. Specifically, there are three characters that should always be escaped to make sure they don't cause rendering issues either right away or down the line. And these characters are the following: the less than character, the greater than character, and the ampersand. Instead of using the less than character, you should use the HTML entity, which starts with ampersand and then followed by LT semicolon. So if you put in your HTML ampersand LT semicolon, what the browser will interpret this as a less than character. And similarly, for the greater than character, it's ampersand GT semicolon. And for the ampersand, it is ampersand AMP semicolon. So let's take a look at some HTML to see this concept in action. Okay, so we're looking at a document called HTML entities before.html, which is located in the examples lecture 08 folder. And this document contains a quote from one of the US presidents, Theodore Roosevelt, which happens to be one of my favorite quotes of his, and a very weird looking heading 1 content. So we can take a look at it. It says, don't be afraid to be, then the less than sign, then 100% success, ampersand, greater than, more, and semicolon. So let's take a look at what this looks like in the browser. As you can see, our heading didn't really do so well. It says don't be afraid to be more, and there's a whole bunch of words missing here. Well, the reason this is going on is because the browser is interpreting this left angle bracket as a beginning of a tag. And then it looks at the word then, it doesn't quite understand what kind of a tag that is, and basically skips just about everything between the left angle bracket and the right angle bracket and just says the word more. So we could fix that very easily with substituting the less than angle bracket with the HTML entity reference. And once we're at it, we might as well substitute the other two characters, the ampersand and the greater than. We'll save the document, go reload our web page, and as you could see, the entire heading 1 tag content is displayed on the screen. In reality, HTML contains a whole ton of different HTML entity references, and obviously we're not going to be able to go through most of them. However, one particularly common one is the copyright symbol. And the main reason why we would use an HTML entity reference for it is because it's not really very readily found on any keyboards out there. However, you could very easily put that in, so let's go ahead and put it right here after the year. And the copyright entity reference is just ampersand copy semicolon. So let's save it and reload it in our browser, and here's the copyright symbol that's appearing right after the year and before the word copyright. There's another HTML entity reference that is very commonly used and unfortunately a lot of time misused as well. Let's say, for example, that in the last sentence here that ends, timid souls who neither know victory nor defeat. Let's say we wanted the word victory, no defeat, never to wrap and would always stay the same. So what do I mean by that? Let me pull the browser and make it a little bit less wide. And as you could see, the word victory, no defeat is split up into different lines. Let's say I didn't want that. For whatever visual reason, I wanted the words victory, no defeat to always stay the same. So if it is going to wrap, it should either not wrap at all or wrap altogether. Well, the way you do that is with a non-breaking space. So, and the way you use it is NBSP, semicolon, non-breaking space, removing all spacing in between the words. So now let's take a look what it looks like in the browser. We'll go ahead and refresh it. And now you'll see that the words victory, no defeat, as we squeeze the browser and make it a little bit less wide, they will either both drop to the next line or they will stay on the same line, but they will not be separated anymore. But let me caution you about misuse of this entity reference. A lot of people use this entity reference if they want to make a space between, let's say, the word critic and the word who. And they will put a few spaces. Let's say they need a few spaces in it. And if I now refresh the browser, I see now got a few spaces between the word critic and the word who. And that's a total misuse of this entity reference. If you ever wanted to have spaces or extra spaces between some words in the text, what you would do is you would probably wrap around some text in a span tag and then apply some margin, in this case left margin, to the span tag to remove it further from the word critic. But you should never use the non-breaking space HTML entity reference for that purpose. Let me show you another HTML entity reference that is very commonly used. And it's especially useful when somebody's trying to write an HTML-based email, since the email clients are notorious for using a much more limited character set than UTF-8. Some of the characters sometimes get messed up. So let me show you what I mean. Let's go to the web page, and instead of viewing this web page in UTF-8, we'll change the encoding to something more limited like Windows 1252. And if you notice, some of the quotes became these very weird characters. So how do we solve that? Well, the way we could solve it is by using an HTML entity reference of quote. And if we preview this in the browser again, and let's refresh the browser, and now there are quotes. Maybe they're not the same type of curly quotes as before, but they're quotes nevertheless. So in summary, we looked at HTML entities, and they help avoid rendering issues, and especially with those 3 characters that HTML can try to render instead of thinking of it as content. We also saw that sometimes you could safeguard with these HTML entities, safeguard against more limited character set encodings. And you could provide characters not available on the keyboard. For example, like we provided the character of copyright that was at the end of the document. That certainly is not on any of the keyboard that I've seen, but you could still display that character using HTML entity. Next, we're going to talk about making text hyper with linking.